Bivariate correlation. This is one of the statistical tests that can be performed in SPSS. Bivariate means two variants or two variables. The test looks for a relationship or association between two variables or two groups or two samples. The test that is used is usually Pearson correlation coefficient. The test is used when the data are normally distributed and the variables within the data or the scores within the two groups are normally distributed and are continuous. So it is a parametric test. This test is used to find the relationship between those two variables or two groups, measure the strength, how strong is it, from a scale of -1 to +1, as +1 is the strongest relationship, -1 the strongest relationship, but it's an inverse relationship, 0 as there is no relationship. So the test will measure the strength of the relationship, the direction of the relationship, whether one variable increase, the other decrease, or the one variable increase, the other increase, or there is no one increase, the other has no association with the first one. So the test will measure the strength, the direction, and the significance of this relationship. So Pearson's correlation coefficient will determine the strength of the relationship on the scale of -1 to 1, the direction of the relationship or the association, and the significance of this relationship. And the way to do that is, here I have a data in SPSS for 4 groups labeled as data 1 to data 4. And on these groups there are scores, and I want to find out the relationship between data number 1 with 2 and data number 1 with 3 and data number 1 with 4. The first step in doing a correlation test such as Pearson correlation coefficient or a parametric test is to look at the data through a scatter plot, to look at the data and to find out whether what type of association between them, the relationship, the strength of the relationship, the direction of the relationship. Scatter plot will allow looking at the direction of the relationship and whether there is a relationship or not, and whether there is an outlier or not. The first thing is to do a scatter plot. To do a scatter plot, click on the graph, legacy, display, and then scatter plot. I'm going to use simple scatter. Click on continue, reset this. I'm going to look at the scatter data between data number 1 and data number 2. And if I click on OK, a scatter plot is generated, and as we can see here from this plot, the relationship between data number 1 and data number 2 is not defined. So there is no association between data number 1 and 2. When data number 1 increases, there is a random increase and decrease on the data. So here I can fairly say that there is no relationship between data 1 and data 2. I can confirm that by doing a correlation test using Pearson's correlation coefficient. The way to do that is to click on Analyze and then scroll down to Correlate, and then go for Bivariate. Click on Bivariate, reset this. In this Bivariate, I'm going to correlate between data number 1. So I'm going to move data 1 into variables box, and then I'm going to also transfer data 2 into the variable box. Here I'm going to select the Pearson coefficient for correlation, or correlation coefficient, and I'm going to ignore the Gindel's 2B and Spearman correlation, as I'm going to describe this in a separate video or separate videos. And since we don't know the relationship between this data, so we always safe to stick to test of significance for two-tailed. However, if I know that data 1 and there is association between data 1, which is increase or decrease, I can choose a one-tailed significant test. But here I'm going to stick safely to as a default for two-tailed significant test. And I'm going to flag the significant correlation. If I click on options, it's not a lot of to choose, but I might select mean and standard deviation. If I want to look at how the mathematical calculation of the Pearson coefficient, I can select the cross product deviation and covariance, but I'm not going to select that. Click on continue, and scale and the style, I'm not going to make any changes. If I click on OK here, what happened here, as we can see, this scatter plot shows that there is no association whatsoever between data 1 and data 2. Pearson correlation coefficient has been calculated using SPSS. In the first table, we see here that the data, the mean and the standard deviation for each, and in the second table we see a correlation between data number 1 and data number 2. Again, as we say here, if we compare data 1 to data 1, of course it will be, the correlation will be perfect, and the value for the correlation coefficient will be 1, which is the maximum strength, because you're comparing the data to itself and there is no significant. And as we can see here, the number of the data are 86 scores. Now if we compare data 1 to data 2, we can see here that there is a minus 0.08. That indicates there is a small inverse relationship, minor inverse relationship between data 1 and data 2. But again, it is 0.01. So this is really very, very, very low, and it's even, there is no significant. We can consider there is no correlation between data 1 and data 2. This is backed up by the p-value, as the p-value here is 0.45, which indicates that it is really not significant. So here we can safely state that data 1 does not correlate with data 2 at all. So there is no significant association between data 1 and data 2. So that's for data 1 and data 2. What about if I want to compare data 1 to data 3? Again, I'm going to repeat the same thing. Draw a scatter plot. Going to move data 1 to y-axis, data 3 to x-axis, or vice versa. If I look at the diagram here, a scatter plot, I can see here that there is a fairly positive relationship between data 1 and data 3, as there is an increase when data 2 increases, data 1 increases. So there is an indication that there is a relationship between those data. To confirm that through a statistical analysis, I will do a Pearson correlation test. So if I click on data, again repeat the same step, keep the same thing as before, click on OK. Here again, correlation table is generated. And now if we compare data 1 to data 3, we find out that there is a correlation coefficient, or we call it here the R. The R, Pearson correlation coefficient is called R, and the R is 0.55. That is really a moderate relationship. And the sign here is positive, so there is a positive relationship, which means that when data 1 increases, data 3 increases. And this association is extremely significant, as the p-value is less than 0.05. So there is a strong correlation, as we can see here from the scatter plot and from the statistical test using Pearson's correlation coefficient, that there is association, a positive association between data number 1 and data number 2, and this association is statistically significant. Now, if we move again to try to compare data number 1 with data number 4, repeat the same thing again. Scatter plot, remove data number 3 from here, replace it with data number 4 and hit the button for OK. Again, from the scatter plot comparing data 1 with data 4, I can see here the inverse relationship. When data 2 increases, when data 4 increases, data 1 decreases. When data 4 increases, data 1 decreases. So there is an inverse relationship. To confirm this, you need to do a statistical analysis. The way to do that, to go to correlation, bivariate, reset that. I'm going to select compare the data between data number 1 and data number 4. I'm going to keep everything as before. Again, here the correlation says that there is a correlation between data number 1 and data number 2. As we can see here, the value for R is minus 0.722, which indicate that this is an inverse relationship between data 1 and data 4, and since it's minus, and the relationship is really strong as it is 0.7, and it is significant at the p-value for the statistical test, and the association is really below 0.05. So the graph, scatter plot graph, and the Pearson correlation coefficient R indicate that data 1 and data 4 are associated, and they are in fact negatively associated. There is an inverse relationship between them, and this relationship is really strong. You can call it a strong relationship, and it is significant. So this is the way to do correlation and or association test between two variables. Look at the scatter plot and then backed up that with a statistical test for Pearson correlation when the data are normally distributed and continuous. And Pearson will inform you whether the data are positive or negative. The data correlate to each other positively or negatively, whether the correlation is significant, and the strength of this correlation or length or association.